Hi, I'm Jamie Boss. Welcome to my shop. In this video, we're going to highlight 50 tools that I've made over the years and a few I've picked up at tag sales that have made my life a lot easier, both in guitar building and guitar repair. So I hope you enjoy them. We'll be back at the end. Our first tool is a clamping workstation. I made it out of 3/4 inch Baltic birch plywood. It measures 32 inches by 24 inches. The top is rounded edges and the spacing between the top and the bottom is 4 inches. I used cut off pieces of 4x4 to make the space and give the fixture strength. This is an ideal work platform to clamp to the bench and it's got many uses around our shop. The second tool is on the bottom of the work platform. I just flip it over, clamp it to the bench, and use sandpaper stuck to the bottom side as a sanding surface for large and small guitar components alike. I typically use 120 grit sandpaper. I use the Black & Decker Workmate for many things. Tool number 3 has 2 padded and braced wings bolted on the top of the Workmate. I just put the guitar between the padded wings and tighten up the Workmate jaws until the guitar is firmly held. I have yet to find a better holder for doing neck resets. Manufactured files used in fret crowning can be very frustrating. The finish is never perfect. After roughing in the shape with a standard fret crowning tool, I use this tool that I made along with adhesive 220 grit sandpaper to go over the crown surface. The tool is made from a block of walnut and I used a rat tail file to mirror the arch of the recrowned fret. It is also great for cleaning up sharp fret ends. The small bench hook is irreplaceable for planing braces and guitar components. My small bench hook includes a guide to plane down thin classical guitar braces. A large bench hook is also very handy around the shop. This one is used for larger components during the building process. Bench hooks are easy to make and simple to use. The close cousin of the bench hook is a shooting board. I use the shooting board for cleaning up the gluing edges of top, back, and sides before gluing. It's just a wide surface made of plywood with a ledge to allow the work to hang over and be trued by a plane or sanding stick. I use my clamping workstation in conjunction with a shooting board to clamp everything efficiently. Tool number 8 is a small sanding surface made from flat marble floor tiles and strips of adhesive sandpaper. My sanding plate has a strip of 80 grit, 120 grit, and 220 grit sandpaper for any small sanding job that might pop up. Sanding the bottom of the bridge can be hard on the knuckles. Here I took a piece of thin rosewood, shaped it to make a sanding handle that slides into the saddle slot. It gives great control and excellent downward pressure and protects the fingers. Quite often I'm in a position that I need to thin purfling or binding before gluing it to the guitar. I made this purfling and binding slicer out of a piece of MDF. I just slide in the binding and plane the excess away. Slotting a saddle is easy if you've got a milling machine. For those of us who do not have one, I made this fixture that clamps into a vise and guides my Dremel tool to make the saddle slot. Using a good grade two-way tape, I just stick the bridge onto the guide, use my Dremel tool to take shallow cuts until the depth is correct. This firm but soft pillow helps to support guitars that I clamp into my padded luthier's vise. The pillow is actually a fixture used in various sewing processes, and it can be made out of a stiff foam as well. I use this every day in my shop. Tool number 13 is a fixture for using the Dremel tool for cutting the sound hole and rosette channels. I simply took the pivot pin that came with a Dremel tool attachment and permanently glued it to an old workstation I had made. Simply drill the centering hole in the top, glide it over the pivot, and start dremeling. A simple vise bench is a great way to clamp items in a position that doesn't require leaning over the bench and straining your back. I just took a fair-sized piece of pine, glued and screwed another piece of wood onto the bottom side, allowing me to clamp it into my luthier's vise. It works like a charm. Sanding round and contoured surfaces like hollows of a guitar neck can be very hard to do. I just take a 4 to 6 inch piece of 2-inch round stock and cover it with adhesive sandpaper. I keep dowels of many diameters around the shop to make custom sanding fixtures out of. For flat surfaces, I always have paint stirring sticks on hand to make sanding utensils. Most paint stores give them away for free, and I get mine from Home Depot. Just put on the sanding paper and cut to length. Item number 17 is a homemade go-bar deck. You can make one by cutting two 3/4 inch thick 18 inch by 24 inch rectangles out of plywood. Buy 4 threaded rods about 22 inches long and drill matching holes in all 8 corners. Cut 4 lengths of PVC pipe to hold the 2 halves apart and you've got a go-bar deck. Fiberglass rods can be bought online, or lengths of wood strips can be substituted for fiberglass rods. This is a great tool for gluing braces and the like. Joining the top and back sections is very easy with this homemade joining fixture. I just took a flat piece of plywood and glued a stop to one side. Cutting 2 sets of ramps, I glued one set of each ramp to a mounting board that can be clamped to the joining board. Once clamped in position, I used the 2 remaining clamps to tap home a tight joint between the 2 halves once the glue is applied and wax paper is put down on the underside. Putting a weight on top helps prevent the 2 sides from pushing up. Cutting pearl inlays can be made easier by cooking up a board like this on the jigsaw. Just clamp it to the bench and start sawing your design. I tape a hose from my air pump to a clip for blowing dust clear of the cutting area. Remember to wear a mask. Carving your bridges by hand can be made easier by taking industrial-grade 2-way tape and pressing your bridge onto a block of wood in the same shape as your bridge. Clamp the block of wood to your vise and chisel and carve away. Holding a saddle while sanding on a sanding plate can be deadly to your fingertips. I just take 2 pieces of hardwood and using 2 long wood screws, clamp the saddle between the 2. This works great for hand sanding plates and belt sanders. Using it on a disc sander can be hazardous. Clamping a bridge that you are re-gluing can be as simple as rigging 2 bolts, washers, and nuts with a matching caul to bear down on the bridge. The bolts are set through the pinholes and tightened to perfection. There is one drawback with this approach. Make sure you put wax paper around the bolt shafts as they pass through the pinholes and on the 2 washers underneath. If not, the glue will squeeze out and lock the bolts into the pinholes when it dries. Using a Black & Decker workmate for a buffer has many advantages. Mine collapses so it can be stored under the bench. The workmate is very sturdy and can be moved anywhere in the shop very easily. I use workmates for all kinds of jobs in my shop. The basic design of a workstation can be expanded into a full-blown assembly form or solera. This one is universal and I use it on both steel strings and classical guitars. 5 2-inch dowels are located on each side of the guitar outline with through bolts. The bolts lie in short slots so the dowels can be moved with precision. The guitar outline is penciled into the top and located on the center line. I rig mine with plenty of holes and wood dowels that stick out from the side so I can use long clamps, spool clamps, or large guitar shop elastic bands. The whole fixture can be bolted to the bench, and because it's adjustable, I eliminate the cost of multiple forms. I routinely make half molds from thick MDF to help with side bending. The half mold gets clamped to the workbench and makes a very nice form for matching when bending sides by hand. The half molds also allow for checking the fit and contour of a newly bent side. Gluing the scarf joint when building a guitar neck can be a slippery job. As soon as the clamp pressure is applied to the joint, the ramp will cause it to slip out of place. I just took a scrap piece of MDF, glued 2 blocks onto it that mirror the position and shape of the assembled neck. The long part of the neck gets clamped to one block, the short part gets clamped to the other. Once both blocks are firmly clamped, the joint can be firmly clamped without worry of slipping. Make sure you put wax paper down under the scarf joint. I never throw away old pickguards or guitars with pickguards. I take the pickguard and make a pattern from MDF. I then glue the MDF to a backing, allowing me to use it as a routing fixture to make duplicate pickguards at any time. I use industrial 2-sided tape to stick the pickguard material to the pattern before routing. Most people use plans to build guitars. I take my plans to a place that makes full-size copies, and I get 2 or 3 duplicates made. I then cut out the part that I wish to make a pattern from and glue it to MDF. Once dried, I cut the pattern out on the bandsaw, and I have accurate patterns to use, and I still have the original plans without damage. The standard fret sawing miter box that is commercially available can be difficult to clamp to a bench, and mounting a long fretboard for sawing can be awkward. I added this base to my miter box that allows me to grasp the unit firmly in my luthier's vise, and the added length and pads support the long fretboard nicely. I bought this multiple pants hanger at a tag sale. With a little imagination, I just hung it from the ceiling and now have a place to organize my full-size plans. The typical production routing pattern for dovetail joints usually comes with a set of plans to accommodate the clamping of the body and neck. The plans are well designed and easy to make. I did, however, overdo it with supporting mahogany braces. Once I bolt this to the bench, it doesn't move an inch. Shaping a neck with a spoke shave can be difficult to hold in place firmly. I made this neck fixture out of thick MDF and can easily clamp to a bench or workmate or grasp it in a vise. I attached the neck with strong industrial 2-way tape. Maintaining the radius of the back braces when gluing can be hard to do. An assortment of curved dishes can be expensive. I use available radius patterns to make cawls that can be placed underneath the back when clamping in the go bar deck. Easy to make and easy to use and very inexpensive. Removing old bridges, fretboards, and parting backs that have come loose requires a thin, long, wide, and strong blade that flexes easily. There's nothing like an assortment of old cooking and baking spatulas, especially ones from the 50s and 60s. I found these at a tag sale and in my mother-in-law's kitchen drawer. Roughing out the height of a saddle can be simplified by using 2 blocks of wood held around a ruler with elastic bands. Just rest one end on a shim at the height of the string of the first fret and slide the ruler up and down and estimate the height of the new saddle. Electric planers work great for thinning out sides, tops, and backs. A simple plywood base with a stop built into the front allows the planer to make cuts thin enough for guitar components. I run my plywood base through the planer first to level it and then coat it with lacquer to keep it from warping with humidity. Using a drill press with a safety plane is made easier by adding a wide shelf of MDF. The shelf can support wide backs and tops. Make sure the shelf is level to the cutting blades. Use of commercially made guitar molds can be improved by making internal jacks for pushing out the waste and far ends against the mold. I made these out of thick MDF and 1/2-inch threaded rods with nuts and washers. The outside of the MDF is covered with felt. Saw blades used for Dremel tools are very thin and very strong. I drill a hole in a comfortably shaped wood handle and epoxy the blade in place. They're perfect for cutting string slots for tapered pinholes. Using long clamps to squeeze the top together to close up a slight crack can be risky. I make cawls that match the outline of the body shape and then use long clamps to gently pull the sides in. If a gentle pull of the clamps doesn't close the crack, I push glue into the crack with my fingers and give the interior of the guitar a quick shot of steam. With the clamps gently pulled in, the crack usually closes up. Cutting the longitudinal sides of a traditional pyramid bridge can be tricky. I made this angle cutting tool to be used with a bandsaw. I mount the bridge using two-way tape to the angle cutting fixture and cut the two sides of the pyramid on my bandsaw. Here I took a standard industrial dial indicator and made a fixture from MDF and mahogany. I designed it to be clamped in my luthier's vise, allowing one-handed use for measuring side, top, and back thicknesses. There are so many parts to the guitar building process that I found I needed a vertical clamping bench. I made this one out of some heavy pine with solid bracing to clamp to my bench. It's great for working on headstocks and dovetail joints. Using commercially available radius patterns, I made this radius sanding fixture for putting a radius on guitar sides to match the radius of the back. They work as good as a concave sanding fixture and are very easy to use. Locating a fretboard in the center of the neck is helped by making a pattern of the fretboard final shape and putting two large holes in each end of the pattern. I can just look through the holes and align the center lines of the pattern with the center lines drawn on the top of the neck. The commercial slotted tuner jig is very expensive. I just saved an old classical guitar neck and carefully cut the headstock in half. It makes a perfect drilling alignment tool for drilling slotted headstock tuner holes. Occasionally I need to set the radius of just one or two frets I've replaced, and I don't want to redo all of the frets. I took my commercial fret radius sanding block and cut off a small section. Now I can finish the radius on just one or two frets and don't have to redo all of them. I'm always on the lookout for weights to hold gluing sections down. These old cast iron irons are great for the job. I just put felt on the bottom and put them to work. Adjusting the two side slots on a classical guitar neck can be tedious. I made this pattern that has the correct thickness and slot angle for checking the slots as I'm making a classical guitar neck. There are so many angles that need to be shaped when making a saddle or nut that I took an old electrical component vise that has a ball socket and screwed it to a block of wood for bench clamping. Now I can put my nut vise into this fixture and move it anywhere I need to. So that's our 50 tools. I hope you enjoyed it. We do have a little bit of a bonus. This next section is how to determine the fret positions using what we call the tangent line method. So if you don't have a fret position ruler or a fret scale ruler, you can use this method to determine the fret positions for any scale. All you need is the first measurement from the nut to the first center of the first fret, and everything else will fall in line. So we'll be back after that. Now, one of the problems with making a new fretboard is you have to figure out where the fret placement has to be. And either you're going to check your old fretboard or you're going to make the markers or the positioning for the new frets on the new fretboard. You still need some way to measure it. Now, we could use special tools, we could use a special ruler. There are a lot of different things that we can do. You can even look in specific books, and for the length of scale, it will give you the individual measurements. If you're going to use the individual measurement method, okay, it can get kind of cumbersome because sometimes the decimal places go out to 4 places. Kind of difficult to mark off each fret. So what I'm going to do is I'm going to show you what we call a tangent line. And let's imagine that the scale that we're going to use is going to be 25 inches. And I would go to a piece of paper that was big enough, and I would draw out a line that's 25 inches. So from here to here is exactly 25 inches. Next thing I would do is I would get myself a square, and at the end of the line I'm going to make a 90-degree line straight up. Now, I would go to a book, and for the 25-inch scale, I would get the measurement for the first fret, from the nut to the center of the first fret. So let's say I do that. I go to the book, I take my caliper, I mark off the measurement. In this case, I'm going to use a compass. So this is the measurement now between the nut and the first fret. And I put it right on this center point. And let's make it, this is going to be out of scale so you can see what we're going to do. So now I'm going to just draw a radius down to the bottom line. Okay, so we have a nice radius. So the tangent line is going to go from this point here, where this radius hit up here, to the very beginning of this line. So as best I can, I will try to make a straight line for you. All right. All right, there we are. So now we have what we call the tangent line. The tangent line is going to make it very easy for you to figure out the individual fret placement, as long as you have your scale correct and this measurement was correct, and you came up and you're from at the very top of this radius and at the very beginning of the line. So once we do that, I'm going to go to the beginning of that radius, I'm going to take my square, and I'm going to draw a line straight up to the tangent line. Next thing I'm going to do is I'm going to take my compass, put it right down here at the bottom of this straight line, and I'm going to put it right at the top of this tangent line and draw another arc down. Okay, that is now the placement for the second fret. Then I'm going to take my square again and draw a line straight up, and again take my compass, bring it down to where the 90-degree line intersects the tangent line, and bring the radius down. That now becomes the position of the third fret. And we continue on for as many frets as you plan on using on your fretboard. Now obviously using a sharp pencil is definitely going to help, but if you had to measure out the frets, this would be a very interesting way of doing it, because you only have to worry about the measurement once. Then after we marked out all the frets that we're going to use, we would cut this out, and we could tape this portion to the fretboard that we're going to use and put the individual marks on the fretboard, and from there it's just a matter of sawing the slot for the fret. So this is called the tangent line method. And so we're going to now go on to some of the tools that we can use in lieu of the tangent line, or measuring out the location for each individual fret. So I hope you enjoyed the video. See you next time around.